corrections to the agendas.
Parking lots.
And also,
That'd be
I
cool.
see, is
Yeah,
that
that'd be
printed
cool.
the summary from last?
Yeah, I think we only have like 20 copies of the notes.
Yeah. So if anyone has not seen the summary from the last CAG meeting and would like to, there's some copies of those too. Feel free to share.
I'm good, thank you. How about you?
So everyone should have an agenda for the meeting and also a handout for the first presentation that we're gonna have. That looks like this.
Oh, that one.
So will you, raise your hand if you don't have, the agendas are going around, I think, right now. Raise your hand if you don't have the presentation.
I have to cleanse my palate.
Okay. And here's a meeting summary if you need it. I think I'm gonna have them up here. Let's come on the meeting summary from last meeting. You look like very busy.
Agendas, anybody?
Thank you.
Okay, everyone, well, welcome to our monthly CAG meeting. I love that we have really big attendance on the one night that we have a really small space. But thank you for the city and to Karen, who can't see because she's hiding, for arranging a space. So the idea was, thanks to the Lowry Trust for providing dinner. Karen doesn't want to sit. Thank you, everybody. Thanks for independence. And so and thank you for the tour. Many of us just went on a tour of the site, which is really, really helpful and informative and well done, well put together. And so thank you for that. Because we have dinner, we couldn't meet at the school like usual, so that's why we're meeting in this spot. But next month, hopefully, we'll be back. No?
You know, the school's pretty different this summer.
Oh, right, okay.
We may want to explore some other
Okay.
options, and we have ideas, I'm really open to suggestions, so.
So at the end of this meeting, we'll talk about possibilities for venues for the next month's meeting.
Light.
Maybe a bigger room.
It could be right here, and we can see how people feel about it.
Tom and Emily's place is great.
And Karen can get a bigger room with more notice, so that might actually. So for those of you who have not been to CAG meetings before, what we usually do is I'll give you a sense of the agenda for tonight. And we're just going to do a quick go around so we know who's in the room. Usually we have name tags, so we don't really have enough room for them. Tonight, plus Bonnie stole them after the last meeting. So do you want to say anything about the video?
Just so everybody knows, you are being streamed and videoed and recorded. So give us your best.
The idea is if people can't make it, they can listen.
Yeah, just so you know.
So the purpose of tonight's meeting, at the end of the last meeting, there were a couple of requests. One was to have a presentation from EPA about 1,4-DAC saying in terms of the lab analytical detection detection limits and methodologies, and just getting some input regarding those topics. Then we're going to also have a presentation and discussion with work settling defendants regarding delineation of the offsite plume and some of those efforts. We've switched the order, so initially we were going to have the work settling defendants presentation first, but because it's just logically, I think made more sense, we're going to switch them and hear from the EPA folks first. But before that, in a second here, after we do a quick round, we're going to hear some updates. EPA has a bunch of updates of things that have happened since our last meeting. I know the CAG the community members had their monthly work session, and they may have some things to also share before we launch into the discussion. So I think without further ado, I'm just going to go around this way. I'm Ryan Wilson. I'm the facilitator for the CAG. I work with the Consensus Building Institute. More making Karen stand up. I'm so sorry. Food in your mouth. You're in Top City, Aurora. You do. And also, if you're a member of if you're a community member, please, if you could share your neighborhood where you live generally, and if you're with an organization or agency, please share what's within.
I'm Steve Miller with Arapahoe County ex officio.
And I'm Bonnie Rader. I live in Thunderbird Estates, and I'm the CAG chair.
Margie Sobey, Murphy Creek, community member.
Molly Smolin, Murphy Creek, community member. Jessica Reed, south of Murphy Creek is where I live.
Dave Wilmot, City and County Denver ex officio.
I'm Steve Recknell with Waste Management.
Dave Chamberlain, senior hydrogeologist with CDM Smith, consultant to WSDs.
Keith Homersham with Tri-County Health Department.
And Rebecca, can you hold up for a second? We'll start with Sarah and do the background.
Sarah Teschner, hydrogeologist with EPA. Rita Courthouse, planner with City of Aurora, downstairs.
Don Langley, community member.
Janine Natterman, public information officer for the State Health Department.
Bruce Peterman, the subcontractor EPA.
I'm Jennifer Harrison, EPA Community Involvement Coordinator. Jennifer Webster, Blueprint Strategies on behalf of the town.
Scott Hutchings, I'm the Director of Government Affairs for Waste Management.
Jennifer Rivera, because Jennifer to go. I'm the Director of Communications for Waste Management.
Then I'm Rebecca Thomas with EPA. Lynn Burrell with Parsons.
Steve Funningsland with CDM Smith. I'm a hydrogeologist.
Arthur Frickle. I'm a community member. From, I live at Hampton and Tower, approximately.
I'm John Barber, community member from Traditions.
Richard Rader, Thunderbird Estates, community member.
Tom Kraus, Thunderbird Estates, co-chairman of the CAG.
Maggie Branch, I'm a community member and I'm a resident of Murphy Creek.
Scott Wilson, the Air Force Civil Engineering Center. I work at your friendly neighborhood Air Force Base, Buckley Air Force Base, in their environmental program. Lead with the State Health Department.
Hiding in the corner, Lori.
There you are.
With BWT subcontractor to EPA.
You're going to be hearing from Lori in a minute on her presentation. So Rebecca, I know that you're just pulling out your cookies and don't eat it yet.
Oh, yeah.
Because what I would love to do is go into any announcements, follow-up from our last meeting. And I know, Rebecca, you had some items that you wanted to share with the CAG, and then we'll hear from others if there are other announcements or follow-up from the last meeting.
Thank you, Ryan. And I would just like to start out by repeating what you've already said, but thank everyone so much for the tour this afternoon. You planned the weather really well. The tour was great. Appreciate your working out the transportation and all that. And one thing, Ryan, you didn't mention, I'm also deeply grateful for the spiced nuts recipe, which didn't make it home last CAG meeting, so thank you very much for that. So in terms of what we've done at EPA over the last month, and I should mention too that Les Sims sends his apologies. He couldn't be here today because he's with his son graduating from college, but we plan to see him again in June. So I wanted to follow up from our last CAG meeting, and again, thank you for the resolution that was provided and also the correspondence, the new correspondence, which also included the clean letter from a number of years ago, stating some of the concerns that the communities and the CAG members have. And we certainly acknowledge those concerns. I think a lot of those questions will be answered as we move forward with responding to the issues that were raised in the 5-year review. So I did just want to again acknowledge the effort that you made to put that information together. We've received it, we're taking it seriously, and the hope is that as we all collectively move forward together on responding to the issues raised in the 5-year review, we can answer some of those very important questions. And for me, those questions boil down to what potential exposures are there, in particular to the 1,4-dioxane plume, and then also how well have we defined that plume boundary, and how might that plume boundary be influenced by the injection of potable water. So those issues I know that have been raised by the CAG are also issues that the WSDs and CDPHE and EPA are working on. So I just wanted to start out with that acknowledgement.
And Rebecca, is it fair to say that at some point when the time is right, you will be able to report back to the CAG how those concerns are being incorporated or not? Is that something that the CAG can?
Yes, you jumped ahead a little bit.
Oh, I'm sorry.
Sorry. Yes, Ryan, we will do that. Before I was going to get to that point, I also wanted to make note of the conversation that we had when Dave and Chris were giving us such a nice tour of the biological portion of the water treatment plant. I know there's a lot of conversation during that portion of the tour about the various groundwater aquifers, the depths to the various aquifers, and how contaminants might travel through that whole system. I know that we do have, I don't even know how many shallow wells, lots of shallow wells, some deeper wells. But I think that's one of the questions too that we're all interested in fleshing out a little bit more is, do we need to be concerned about contamination in those deeper aquifers? And that's also something that is in 5-year review. So I would like to propose that that might be a topic for a future CAG meeting. I don't know exactly when. I don't know if we have ourselves pulled together to do that in June or not, but I think that would be a good topic based on the conversation during the tour today. I'd also be kind of interested in coming and talking about what is 1,4-dioxane and talking about the toxicology of 1,4-dioxane a little bit. I know that we talked about it a little bit at the CAG meeting last week, and maybe there was a sense that we should wait until we have collected some additional data from residential wells that are being used in the neighborhoods. But I think there might still be some value in sharing some of that information about 1,4-dioxane itself, even in advance of doing those monitoring collections. So I just wanted to put that out there as a potential topic. So now I'm going to get to where Ryan was trying to jump me ahead earlier. How are we going to answer all of these questions? And there is a lot of work for us to do. And again, when I say us, I mean us collectively, CAG, WSDs, EPA, CDPHE. And right now we've got a couple of meetings scheduled among EPA, the state, and also the work settling defendants. The first one is next Tuesday, May 22nd. It's an all-day meeting, and I sent out the initial invitation to, I think, 10 people with 3 optional invitees. It was going to be a technical all-day meeting, and I counted my attendees last night. We're up to 21 now. So there's a lot of interest in what's happening in this landfill and a lot of interest in the technical issues. So that will be our first all-day technical meeting, and we'll be talking about things like a master schedule, how and when are we going to answer all the questions raised in the 5-year reviews, and we're talking about a couple of draft work plans that the work settling defendants have already pulled together, including talking about the injection of potable water and cessation of that injection of potable water. And then that will be followed up by another half-day meeting on June 2nd. Same crowd of people plus a few. I think it'll be even larger than 21 people. But again, just trying to get the agencies, WSDs, all on the same page and all working as efficiently as we can to answer those questions. So I'm hoping that by the time we get to the CAG meeting in June, we'll be able to share a little bit more about what our schedule might look like and what next steps might look like. And maybe that will help also inform what future topics for future CAG meetings could be. What else? I think the only other very quick update I have is EPA has taken a look at our website. We've done some updating to our Lowry landfill website. We had some old dated information on there that preceded the most recent 5-year review, which was no longer accurate. So we've updated our website. And I think the work settling defendants have also at least removed that link to EPA's old information from their website. So hopefully those websites are a little bit fresher and reflect the information in the most recent work that's been done. That's what I have for updates today, and we have Lowry here with PWT, one of EPA's contractors, to talk tonight about analysis of 1,4-dioxane and the issues with detection limits, which was quite a point of conversation at the last meeting. So hopefully we can shed some light on that tonight with Lowry's presentation.
Okay. Any questions for Rebecca? And then I was going to ask the CAG co-chairs if you all have anything to report back from your study session or any questions or concerns. But first of all, any questions about anything Rebecca just said? Meg?
I could be very confused or very wrong, but I thought a few meetings ago, I don't remember who said it, but, and I don't want to pick on Les because he's not here, but
Well, that's the time to pick on it.
I thought I heard him say that the injection of potable water had ceased already.
It has not. That's a question for us that we'll be talking with WSDs about.
So did I mishear? Did I make that up? Was it ever said by anybody?
I think it was said, but
I
I
think it
don't
was
know that
said,
it
too.
was to take place immediately. I think that that was something that they were going to look into and
That
come
could be,
up
you
with.
might have been talking about some future event.
Yeah.
It's certainly one of the topics that is high on the list of things to talk about.
The 5-year review required us to prepare a work plan to do that.
Mhm.
That work plan will be in EPA's hands in the next week.
Okay.
Good.
All
Yeah.
right, thank you.
Thank you.
Tom, Bonnie, do you all have any announcements from your work session, study session? Do you have any questions, things you want to share with Kat?
Yeah, we do. Number one,
And can everyone hear back
can you
there?
hear back here?
You might have to.
Oh, that's too bad.
She's not gonna stand up.
Here the microphone.
I can stand up.
No, stand up, please.
Thank you, we're not getting there. At our work study session, this last week, the first thing that we talked about was the fact that we think that the EPA is moving forward in assisting this CAG very well. And we want to be sure and thank Jennifer Harrison for all of her work that she's been doing on the CAG website, because that's been a real difficult issue for we citizens. And
The EPA website?
the EPA website, yes, and some of the issues that have been out there, that the water is okay because nobody's drinking it. We don't have that information for sure yet. And so we really appreciate this. And we also are appreciative of how the CAG meetings are going, how well they're being managed, and the support we've gotten from EPA, and the state has been just wonderful. So we thank both the state and EPA. But we were really, I'm sorry, Rebecca, but we're so disappointed to get this latest letter from Les Sims, because it seemed like one of the letters that we've been receiving since 2005. And so I'm glad to hear what you said tonight, that you're going to respond and everything. But for the rest of you, the reason we were so disappointed is because the CAG, until we are given a grant, a technical advisor grant, to hire a technical advisor to come on board for us, the CAG has chosen to adopt a lot of clean Citizens for Lowry Landfill Environmental Action Now documents that were put together for us citizens by our technical advisors. And we think that they're still important. And this last set of documents that we handed in were from a long time ago, 2014 in fact, and they were comments on the groundwater monitoring plan, and we believe none of the issues in there had been addressed yet. So after the last meeting, Les Sims asked me if he needed to answer every question on there, and my response to him was no. What we wanted to be sure of was that EPA's contractor, PWT, would see our comments and incorporate our comments and concerns into their study. Because the work we've seen from PWT so far, we have respect for, and our technical advisors have done work with ROM before. And we just feel that these issues should be brought to light. If we presented them in 2014 and they were never, and I know, Rebecca, what you're saying, that they have been considered to a degree in this most recent 5-year review. But what we really wanted was assurance that EPA's contractor would get a copy of our comments and would be using them incorporated in with their future work. And Les said to me that if he sent the comments to their EPA contractor and CC'd the CAG, then we would know that he had sent the information to them and that he had asked them to include this in their review. And I guess I kind of wanted that to happen, and so did the rest of the CAG. And so when we received this letter, we were really disappointed, because we've been getting a lot of these kinds of letters since 2005. And it was disappointing to once again get a letter that said almost nothing in response. And there's no assurance here that our comments have been given to PWT. And so, Rebecca, your comments tonight have taken some of the sting out of it, and I understand these things happen. I think the rest of the CAG understands these things happen, but we just hope it doesn't happen too often, because it's really discouraging. The second thing is that we discussed the 1,4-dioxane plume and the fact that we've been pushing to have it clearly defined. We came to the conclusion at our meeting that we're all focusing so much on 1,4-dioxane, and that we would feel more comfortable if instead of focusing on 1,4-dioxane, and we're not criticizing the presentation tonight, we need that presentation, but there's leachate coming from that Superfund site. And so we would like to focus more on leachate from the Superfund site. What properties is it impacting and where is it going? And we would also like to talk about the infrastructure that the City of Aurora planning has approved between Yale and Jewel, because some of that infrastructure is actually in place now. And we're curious about whether or not leachate may be traveling in that infrastructure into different ways than just down Murphy Creek itself. So those are the issues we discussed at our work study session. Tom, do you have something to add?
No, that's good.
Okay. So anybody else have anything to add? So basically, I think that's it. We still want to thank you very much, Rebecca and Jennifer and Janine, for all the hard work you've all done. Thank you so much, because this CAG is starting to produce real work, and we're really pleased.
Well, Bonnie, I appreciate you bringing up your concern about our response to your letter. It's important for me to hear that. I think it's important to have the proper dialogue and make sure we're getting issues out on the table. So I appreciate you bringing it up in the manner that you did, and we'll do better.
Great. Thank you.
Thank you.
I don't need a big discussion, but I just wanted to ask you, when you say infrastructure, can you just give me a little bit more on what that is?
You talked about Aurora planning.
Yeah. The City of Aurora was presented with, well, as you know, when the developers are developing a section of land, they have to put down money towards putting some infrastructure in, and if they don't do it within a certain amount of time, they lose their money. And so the people, and I will let Murphy Creek people correct me, I'm not sure if it's Albert Brothers or somebody else, have been, had to put in some infrastructure in between Yale and Jewel. And it's not complete infrastructure. It looks like it's just here and there so they can get their money reimbursed.
We're talking about utilities.
Utilities,
Yeah.
water,
Water and sewer.
and so we brought this, and we'll be happy to pass it around, but I don't know if this is the right time, but since I'm doing it, Ryan, we'd like to ask the City of Aurora if we could have this sent out to CAG members. We went to the planning department.
Okay.
What a nice professional bunch of people you have working here. And I'll pass this around, but this shows the orange is the infrastructure, sewer lines, water lines, things that have been put in at the site. And we know the leachate is going that way, and we've always been curious, not just with 1,4-dioxane, but what is traveling north and what may be impacting by these
Green is the sewer.
greens. Well, this is the,
Orange and green.
yeah.
Well, and it sounds from what you said earlier, like that might be something that you'd like some
What?
presentation,
The City of
discussion
Aurora
from the
to
planning.
talk to us about the infrastructure, and maybe we could get copies of, and I can give these to you at the end of the.
Yeah, and usually, and of course, this group is pretty special, we don't always give out water and wastewater information outside the city. Right, there's a vulnerability issue there.
Absolutely.
So as long as I know what you're using it for and that kind of thing, these are printouts that the staff has access to.
Yes.
I will need to get you that, and they probably printed it out for you.
Yes, they did.
Okay. So let me see what I can do. And then Sean is not here tonight, I see, but I definitely want to huddle with him as well. They oversee any infrastructure that's put in as a result of development. So
Cool.
he can be a great person to touch base with. So let me do that for you.
Okay.
And then I'm going to get.
Okay, that's wonderful. And the second thing that we wanted to bring up was the Murphy Creek drainage. This map here, this drawing here shows Murphy Creek, and we've all been so concerned about Murphy Creek itself coming down through by the golf course. But like we've been saying for the past 2 or 3 meetings, we know there's more than one Murphy Creek drainage. And this shows that there's a Murphy Creek drainage just off of Harvest Road, and there's also the Murphy Creek drain right now that we know goes down past the golf course. And so we would like to more deeply talk about Murphy Creek drainage and what it means to the leachate leaving the Superfund site and going onto properties between Yale and Jewel. So I'll pass this around, and you can see up at the top, it has a Murphy Creek sign where it's coming on Jewel, just past Harvest. And then down here where it shows on Jewel Avenue, the actual Murphy Creek that we're testing and paying attention to now, but we'd like to talk about the Murphy Creek drainage and what it really means at some point.
So at the end, so thank you, that's really helpful. And obviously at the end of the meeting, we like to identify what's on the key for the next meeting, but it sounds to me like we already have a number of things, including possibly some real updates about what's happening with the 5-year view and work moving forward, and also these two topics that you just raised that are related in terms of.
And basically what we're looking for is the total depth of the sewer trench, not the pipe, the trench, because there is pea gravel, trench, pea gravel, and then sewer line. So what is that total?
Preferential pathway.
Yes, so that's where we're at.
Yeah, I got you.
Storm's a little higher, and water, it doesn't matter.
Okay.
I didn't even get anything on the water because it doesn't matter.
So it sounds like Karen may have some marching orders in terms of following up with that, but there's also a question of a little bit more about the about the Murphy Creek drainage, and how it impacts those same concerns. And so maybe at the end of the meeting, can we come back to obviously Karen and Sean are going to be important, and maybe they can cover that whole thing, and maybe so we can come back to that.
And if you need us to, we can come down, comment on it, and we can come down and talk with you and give you, you can ask questions about what we're saying.
Yeah, and I'm reading it. I just need to do my homework. I got you. I get back.
I got you.
You know more than I do.
That's okay. I understand exactly what you have to do, so we'll work with you in any way we can help.
Okay. Great.
So just really quick follow-up, the point is the CAG either knows or suspects that some of these underground utilities are intersecting the water table.
Right.
Okay, and that's gonna be the key thing. So if they're all above the water table, then nothing is really a huge concern, but if some of them go below the water table, that would be the issue.
Or if any of the new infrastructure could be connecting to current infrastructure.
Right.
We're concerned about whether something might be traveling, the leachate might be traveling through the new infrastructure into the older infrastructure.
Got it, thank you.
Okay, thank
And
you.
to clarify the Murphy Creek drainage, and if when you have a creek, you're going to have sand and gravel deposit. The creek's not going to stay necessarily in that same bed. There may be 1, 2, or 3 beds that are old that still have the sand and gravel, but then could allow for travel of leachate.
Yep. Okay. I see vigorously nodding heads. Okay, good. Is there any other announcements, requests? Because I think at this point we're going to transition into presentation from Lowry. Yeah, that's a mistake because we switched them. Okay, we may dim the lights a little if we have trouble seeing, and the one thing I want to say while we're getting set up is just that you all may have noticed in the last meeting summary, we had presentations like we're having tonight. There's a lot of information, there's a lot of discussion back and forth. What we ended up doing in the meeting summary, what I ended up doing ultimately and asking for your input, and I didn't get any negative comments about this, but I'm interested in your feedback later, is to capture the questions that people had and the concerns that people had, so that these are things that we can come back to, and EPA is, I know, working on thinking about a more global response to some of those questions and concerns without trying to capture the exhaustive discussion and partial answers. So that was I'd be interested in your feedback on that and how we do that going forward to make meeting summaries useful. So we'll do that for tonight's meeting unless I hear otherwise from you, and we can toy with it. The idea is that they're useful. Okay. So, Lowry, can you just give a quick introduction about who you are, what your background, what you do with Lowry, and
First of all, can everyone hear me okay?
I'm told that I project very well.
You do?
And sometimes I over project, so I apologize if there's any hearing loss. Name is Lowry Peterson Wright. And maybe to some of you that might sound familiar, and to others of you, the voice might actually sound familiar. My background is chemistry, master's and bachelor's in chemistry. I've spent 32 years working either in the environmental field or in a laboratory setting. And for 13 years, I was the manager of the state's chemistry laboratories. That's where you may have heard my name in presentations or meetings. And I was looking around and just like, some faces look familiar, but I'm not certain. So today, we're going to, well, first of all, I wanted to thank you, because it's very rarely that I find individuals that want to hear about what I am passionate about. I try to say something to my family, and all I get are rolled eyes, and the poor dog puts a little paws on his face if I start doing science things. So anyway, let's move on here. So before this overview, what I'm trying to do is really be narrative and provide examples and analogies and stories behind some very complex issues out there and items. And so, just if you have any questions, you know me, I'll say we'll put it in, but if something just doesn't make sense to you, raise your hand, I'd be glad to try to answer that for you. So today we're going to cover a few things. First of all, just a little bit about 1,4-dioxane. Maybe some reasons why chemists do not like analyzing this compound. It's not very nice to chemists, let me tell you that. Next, terminology. I'm sure you've heard a lot of acronyms, and everybody hates acronyms. Well, guess what? I'm going to teach you the long words behind those acronyms, so those people can't fool you anymore. You're going to know what it means and what it does. And next, analytical methods. I bet you've heard these two numbers before, 8260, 8270. I'm going to tell you how they work. And you're going to have that under your belt. And detection limits. Okay, I know this one could be a little tough. I'm going to try to go through it as best I can without going into big formulas and statistics and all that kind of stuff. Just tell you, hey, this is why we use detection limits. Here's how we try to get them. And actually, I've got a hands-on demonstration I'm making a volunteer for. We'll go on here. Okay, isn't she pretty? Or maybe it's a he. I don't know. So that's 1,4-dioxane. And you know, a couple things about it. Look, I got to use a laser together and cats in here. So 1,4-dioxane, it's a nice little carbon ring. This is the backbone of all different carbon compounds. It has two little oxygens. You know why they call it 1,4? Because chemists can count. 1, 2, 3, 4. Oxygen at 1 and 4. Oh, okay. Next, please. Okay, you see this bad guy here? Okay. I mean, look at that. He's got all sorts of arms and legs and things hanging off of him, but guess what it is? Probably had some this morning. Caffeine. That's what a caffeine molecule looks like. And look again. Got that nice hexagonal structure. So let's try another compound. Okay, that one even looks worse, doesn't it? Ooh. Okay, is my time up already? Yeah. Okay. Well, guess what that one is? It's in your bloodstream right now. Why don't you show the folks what it is for us? Cholesterol. Okay, so you know, bigger doesn't mean it's always worse. But one more over here we got in the corner. This is one that is always confused because they're really close to the same name. Dioxane, dioxin. So this one is TCDD, which is the most toxic dioxin there is out there. And finally, just because I like bees and they're becoming endangered, but look how smart they are. They all know about that hexagonal shape. That's why beehives are so strong. Hold on. Okay. Okay. The chemist walks into a bar. Okay.
That's true.
If I would have known that there wasn't a clicker, I wouldn't have been. put in so many animations. Next, please. So one thing, it's highly soluble in water. What does that mean? It easily dissolves in water. It's a lot like water. It dissolves very well in there, and that's why it likes to follow groundwater. A nice plume. Wherever the water goes, dioxin shall follow. Next, it leaches from soil to groundwater. What does that mean? Pour it on some soil. It likes water more than it likes carbon that's in the soil. You know, the scientists use this thing called the optimal water ratio, KOW. That's all it means.
So I have a quick question.
Mhm.
1,4-dioxane easily dissolved. It says if you add water to it, it says to me, if you add water to it, it disappears.
No,
But it
dissolves
dilutes.
It
dilutes.
dilutes. There you go. It's just still
It doesn't go
the whole
away.
molecule.
Yeah, okay.
It's not like sodium chloride that goes to sodium and salt. It's not like salt water. So thank you very much for bringing that up. Next, please. Low potential to volatilize. Another big $5 word there, volatilize. Oil. And think of it this way, when you go fill your car with gasoline, a nice smell coming off. Okay, that's the benzene, toluene, all these chemicals that are volatilizing. You're smelling them because they became gaseous at standard temperature and pressure. Next. Okay, now we're going to get into that terminology. Okay. Gas chromatography, that's what you see. Okay, got that one? That's the long word behind it. Next, mass spectrometry, or MS. And next one, a fold scan. That's not something from the airport. And again, selective ion monitoring, or SIM, as it said. Again, please. Internal standards. And another one, isotopic dilution. Well, I'm sounding pretty smart that I can pronounce these things. And one more, we're going to talk about extraction. We're going to put all these things together. We're going to have a method. And break again. Oh, break again. Yeah, the presentation has been slide version. So what kind of a bear dissolves in water? Polar bear.
How about aspirin?
Yeah.
There.
Well, it's 15-minute presentation.
I don't think the Matterhorn. Does anybody got the Matterhorn? Yeah, you said it was like, I'm not your grandchildren.
No, we also have them handout.
Or else I would do it.
That's true.
But some of the graphics are so nice.
Darn. Want it?
Yeah, but without the pictures, right? I've been warned. Leave the spaghetti alone. Yeah, it doesn't, because I seriously, I'm graphics heavy, picture heavy, text period. All right, you're on terminal. Okay, terminal. Are we good? Okay, so we made it through all those. Good. Let's go. There. Here we go. Okay, gas chromatography. This is what a gas chromatograph looks like. Okay? And the easiest way to explain this, I want you to envision like a marathon. You have a bunch of runners at the beginning of the gate. We all take off. But then some start moving away from the path, don't they? So that's what happens in a gas chromatograph. We have our sample. It's got a mixture of maybe our 1,4-dioxane and a few other chemicals. It's pushed along a column, which is usually like a gel or a solid. Then over here, we throw this gas in, hydrogen helium. That to me is, have you ever seen the sweeper truck following all the runners, races? Okay, that to me is a sweeper truck. And so what happens is these faster guys, they get pushed out by the gas. The slower ones hang around. Some of them, this is what I like about this, is they get stuck on here and they have to buy new columns, and these things cost $800 a piece. It's not fun when you're a chemistry manager trying to save money. So then we go to a detector, and we're going to get something called a chromatogram. So if you go ahead and change the next slide, this is what it looks like. So based on the time, here's your fastest runner coming off. Everybody moves along, the slower ones are out here. So that's how it separates. It's separating on its ability to go through that column. And if we test one more time, right there is our friend 1,4-dioxane. And believe it or not, in 2011, I ran the Denver Half Marathon, and I was finishing someplace way back here. Yes, I wasn't even in the chromatogram. I was even stuck on the column. Run was ahead of the sweeper. Okay, next. So we have a mass spectrometer. Okay, this is something I like to liken it to. You have that compound that's now made it through that column. Got out, he's part of the chromatogram. It's going to go to this really cool detector over here. And what I see this as, and this was the very first instrument I ever worked on when I got out of college. I worked on a great big research level mass spec that took up this entire room doing cancer research. So I love mass spec, and I spent a lot of time doing mass spec. I'll just put it that way. So we take a sample, we ionize it, it gets charged, gets like a static charge to it. And then also based on its mass. So we have, it's hit with electrons, the electrons smash it. So I look at every compound as a puzzle piece. So it breaks apart all those puzzle pieces. Every compound is its own puzzle, okay? So think of compounds that way, chemicals that way, they're a puzzle. The object of this instrument is to break it into pieces so we can identify what puzzle it belongs to. Next, please. So here's our friend, 1,4-dioxane. Here, let's just say this is its puzzle. So we take it, we put it through the mass spec, what do we get? It breaks down. And the signature is repeatable. And what it's based on is actually kind of the molecular weight and the charge of the different ions that come off of it. But this is repeatable. This is what 1,4-dioxane looks like as a map, if you're looking at it from mass spec. Next. So when we take a look at another chemical that we saw earlier, that TCBD, the dioxin. So it's a more complicated puzzle piece. And now if we look at the spectrum, can you see that this goes all the way from 120 up to 330, whereas the other chemical was only up to mass 80. So this one's much more complicated. Next slide, please. So full scan, what's that? That's when the mass spec looks at every single mass that's out there. So we start with some 1,dioxane, then we throw in our dioxin, and then heck, maybe this is coming from a landfill and we've got some naturally occurring organics, or maybe some other chemicals out there. And do you see how messy this is getting? It's really hard to tell. There's one more. Really hard to tell one chemical from another. That's why mass spec is a powerful tool, but yet it can be overwhelming. Next slide, please. So this is where selective ion state comes in. You know, we talked about the puzzle pieces and how each chemical has its own specific puzzle. Well, each of those pieces are very unique. And so what you can do for a chemical is you can pick out certain building blocks or certain ions and just measure those. Instead of looking at that full messy scan, look for the ones that are unique to that compound. And this is how we can fingerprint it much, much easier. And back in the olden days, when I was a chemist, we didn't have such things as selective ion. That's how old I am. Okay, so an internal standard. You've probably heard about this in some of the methods. They say, well, it uses this internal standard. Well, what does that mean? So the compound, an internal standard, is a chemical that behaves in a way that is closely related to a class of chemicals. And that's how a chemist will take that, and there's all sorts of miracles out there, little black boxes that do math for us. And it tells us how much of your compound is in there. And the way I'd like to demonstrate this one, next slide, please. Okay, see a family resemblance? Okay, this is my late brother. He passed away last month. And I wanted to just give him a little homage because he's a wonderful, wonderful man. So you look at him and say, okay, there's a resemblance. Well, it goes a little more than that. Both he and I will only eat steak if it has Worcestershire sauce on it. None of that steak sauce stuff. And you say Chinese, we're going to order beef and broccoli. That's about as close as the similarities go. Click one more time. Now you look at it, he and I share just a little less than 50% of our DNA. Same parents, but we each inherited different parts of the DNA molecule. And, well, sorry about that. So with this, so I'm trying to say here with internal standard, we have other siblings. So does my brother replace me exactly? We have some traits, but I went into chemistry. He's got to have a degree in psychology. I went and started working in the chemical field. He went to Vietnam as a Green Beret. Our paths went totally different. We're not exactly the same. We share some traits, but not everything. So that's where another amazing technique comes in. Now you can change it. It's called isotopic deletion. Now, wouldn't you say a couple of twins are probably a little more similar than my brother and I? Okay, so you're going to hear that term isotopic deletion. So what we do as chemists, is we're really cool, we take that dioxin molecule, we can pull out some of those hydrogens and put out heavy hydrogen. So it's going to be way different. The puzzle's heavier, but it's almost the same compound. So if we do another slide forward, please. So right here, pretty much what we do is we take the regular hydrogen, and I know this one's kind of a little sciencey, isn't it? So take regular hydrogen, you give it a deuterium. It's a heavy hydrogen. Next, please. And voila, we have just made 1,4-dioxane D8. That means we took 8 hydrogens and replaced them with deuterium. And so now look at our puzzle pieces. Remember I showed you those 3 puzzle pieces up here? And look over here, they're heavier. So it's going to sit, the masses are different, but look at the behavior. They both came out of the GC at the same time. These two crossed the finish line at the same time. The only thing that's going to be different is their puzzle. And this helps to quantitate the chemical much better than using an internal standard system. If you look over here too, so we're following this mass 43. All these other chemicals that are eluting or running through that capillary column here are giving off a signal. Over here, you don't have that kind of interference. This is running, almost running along, right? Next, please. Okay, so 8260. This is one that's a procedure called purge and trap, extraction. How do we get that dioxane, who loves water, out of water? And there's 2 different techniques that have been used predominantly in the field. One is purge and trap. And purge and trap means you have a sample, it's right here in the liquid. We go out in the field and spent a lot of time in the field and collected, oh gosh, I can't even count how many samples. That's probably approaching 10,000 by now. But so we have the sample. We're going to bubble or try to bubble out the volatile organic compounds that are in there, of which dioxane is one. Then it's collected in a trap, and hey, everybody remember what GC is? Come on.
Get a spectrometry.
Yeah, see, I've been turning on the chemist by the end of the night. So here, we captured the 1,4-dioxane in a nice little trap here. We put him on the GC, and he goes to the MS. What's an MS?
Mass spectrometry.
Okay, I got whizzes in here. Next, please. Another method is 8270. And this extraction is a little different. Because here it's treated differently with some other kind of heavier weight compounds as opposed to the 8260 method. And so with this, can you see over here, this is a good old-fashioned set funnel. And what it does, it separates things. So just imagine trying to mix oil and water together. You get 2 separate layers. And that's what we're doing is we are taking a water sample and then using we had to do this by hand back in the day, and so we'd shake this, and you'd shake, and I really had some nice biceps back then, so that we could extract whatever chemical we're looking for into the other layer, and then we'd analyze that later. And another slide, please. And another type is called solid phase extraction, and this can either be a disc or a column. And this one, it has its own set of problems, mainly because it doesn't like a lot of material in your sample. It clogs. And if you've ever had to stand, maybe you even actually have to, and watch these things drip for hours trying to get a sample through it. So what it does is you actually wet this column, put in your sample, and the nasties usually come out at the end, because what you're trying to do is hold back the compound of interest that you're after. And then you put in some solvent, rinse it out, collect it, and guess where it goes? Whoop. The GC back to the
gas petrol.
Okay, you guys. Wonderful. And so the current analytical methodology that's employed out at the laboratory for, it's my understanding, for 1,4-dioxide. So it's called 8260 SIM with isotopic dilution. So you guys are whizzes now, you know exactly what this means. So we have a Persian trap to get the dioxane out of the liquid sample. We do the dilution so we can measure the concentration with higher accuracy. We use a GC and MS with selective ion monitoring, where we're just going to look at a couple puzzle pieces. Next, please. Now, this one, okay, I'm going to spare you all the statistics in here, but how do chemists make detection limits? How do you know how low you can go? Well, EPA has actually put out a beautiful method that almost every laboratory around employs. There's other methods out there, but I'm just going to use the terms that I'm sure you guys are familiar with and you've probably heard of them. The MDL, the method detection limit, and a PQL, practical quantitation limit, okay? Are you familiar with those? So how do we find that method detection limit? Well, from this procedure that came out from EPA, which was, not uncontested by some labs because it did add a lot of work. But you take a blank sample, water, you run it 7 times. And some instruments will actually give you a signal because water's, even if it's lab water, it's not always pure. So you'll get a signal. That's your blank signal. Then you're going to take a small amount of your chemical of interest, you spike 7 samples, and you do each sample separately, and I've set it up to make sure that we get not your best effort. I don't want to say, that doesn't sound right, because chemists always are the best. What we try to do is spread it out over different days. Different analysts run it, different instruments, so that you can see the variation. Next, please. So, the rest of that is statistics. You compute some stuff, and then you multiply, and then you come up with a number. I'll spare you all that. I just want to get you through the methodology of how we do it. And talking detection limits, without a discussion of precision and accuracy wouldn't help much. And I think everybody, you probably have seen this chart before. I know it's a standard one out there. But what's precision? It means hitting the target every single time. Okay, so being precise. Right there is where we want to be. There we are. Are we very precise here? No, we're not hitting our target. Now, you can also be very precise, but not very accurate. That means here's where we want to be, but here's what we're seeing. And that can be represented right down here. So here's where 0, like maybe this is 10 parts per billion. But our particular method is hitting here all the time. And then finally over here, you're neither. And so you can tell precision by the width, and then accuracy by the distance away from where you want to be. Next, please. So detection limits, and here's where I was talking about I might need a magician's assistance with this, because something that's always neglected, people hear about this new great method. I heard that you can count 3 molecules in a swimming pool of water of this chemical by this newfangled method. Well, detection limits, as I told you, they're using reagent water, very pure lab water. So I just like to play, maybe that's it. Okay, can we all agree that looks like nice pure water? Okay, so a little demonstration. What is a matrix effect? That means that there's other things in that water. It's not pure water. So let's say, hey, maybe this is some groundwater. Okay, it's got some humic acid, a bunch of other chemicals floating around with it. Maybe some dirt and soil. And, well, maybe this is leaching. Okay, so we got our different colors. Wish I had a little table up here, but here's the hard part. I'm wearing a white shirt. Okay, so this is going to be our 1,4-dioxane. Would you crack that for me, please? Ma'am, would you like to open that one for me? Okay. Okay, so we drop in some 1,4-dioxane. Okay. Can everyone see the contamination pretty easily? Okay, that's what happens when you have nice, clean water you're working with. Okay, how about our groundwater? It's got some humic acid, some fertilizers, some pesticides. Let's see, how does having those contaminants mask what we're able to see? Okay, but can you see it as well? That's what matrix effects do to your sample. That's why we have a hard time in the lab. We have to try to either remove this or dilute it. Here's where it gets really bad. They give us a really nasty leachate sample. If my kids will drink this. Put in the same one drop. Can you even see it? Okay, that's one of the problems we run into in the laboratory. Next, please. I hope that was a good visual. I'll bring that home to you. And so with CDPHE, there is a chemical connotation limit policy. I was actually one of the members of the technical subcommittee on that. Came out with the first set of guidance in 2008, and it actually addresses matrix effects like this by allowing a PQL study among different laboratories in real matrix, so that you account for those effects. So right now, what you have, okay, so I told you, okay, the very first, hope you see there, okay, that is our blank. So let's say we ran 7 blanks. And this is what we get. Then we ran our 7 small spikes. This is kind of the scatter around that. Now this area in here, see how they overlap? So we run into some problems, false positives, false negatives. Now what you want to do is you want to make sure that you've got baseline drop in here. And in an ideal world, I'll show you that in just a minute, get a baseline drop so there's no overlap here. So you know that if you see it at the PQL level, it's there. There's no overlap. And next slide, please. So right here, this used to be the standard. Was that back in 2008? Again, please. Right here, this was 2012, and look, see how the PQL is below, which is wonderful. That means that your action levels here, there's no way you're going to get a false negative or positive on this. It is going to be a real hit. But then what happened? We're all shooting for this number. Now it's below our PQL, but above our MDL. So it's kind of been one of those areas that's got a lot more inaccuracy associated with it. So we love to try to report down here, but always know that there's going to be some problems with either false positive, false negative, or a little higher than what you would like to see in the accuracy around that measurement. Next, please. So, in summary, I told you a little bit about my friend, 1,4-dioxane. Went through the terminology and turned you all into chemists tonight. Went through the current analytical method and tried to cover detection limits and then show you the importance of matrix effects and what it does to the analytical method that you choose. So 8260, 8270, it just depends on your matrix, which one is going to work better and what kind of, either one of those. And there's also other methods out there, and there's methods to be developed, and someday when I develop a molecule counter. So thank you very much for your time this evening.
Are we allowed to ask questions?
Yeah, we are.
I just have a question, maybe it shows my naivety, I'm not a chemist. One of the concerns we have, at least in the site we're talking about, the 1,4-dioxane, is a dilution. So if you dilute it, then how do you know what it really is coming out of the site? If it's diluted, you come out, you're gonna say it's 0.35, but is it really? Because until you understand the dilution, how do
Dilution at the site itself, or the chemist doing the dilution?
Well,
Site itself.
The site itself.
at the site itself. I'm just saying, how do you know it's accurate if it's diluted? It's not, it's by weight in the water, so if you dilute the water,
Then you get down into the no.
yeah, it's gonna look good when maybe in fact it's not.
Is that a question about?
Hold out hope for us chemists, because many years ago, we didn't think secondhand smoke caused cancer. And so we came up with new methodology to get lower detection limits. So cross your fingers, 10 years from now, maybe one of my grandchildren will be the chemist that comes.
Well, I just wanted to make sure I was understanding.
No, you're
because
understanding it
Okay.
correctly. When you get down to that low level,
Okay.
uncertainty is much higher.
I just
That
wanted
was a
to
very
ask
good
if you were,
question.
I just wanted to ask if you were thinking about the injection of potable water when you asked that question, when you were thinking
Yes.
about dilution.
Yeah.
Oh,
So
okay.
I think that's an open question, right? 'Cause
Yeah,
the
well, I mean, I
ability
certainly don't know the answer. Is it just a concern?
As we all know, dilution's not the solution to pollution, correct?
I mean, our concern probably, just to take another step, would be if you dilute it, does it travel faster? You know, does the plume grow faster because, or further or deeper or whatever it is, just diluting it doesn't solve the problem. And I don't know how much of that's going on and what we see. And I mean, I'm not a chemist. I just know what I hear and what I observe and the measurements we get. And then you start asking questions and you get kind of different curves everywhere you look. And it's like, oh my gosh, I don't know if we really know, you know? And then we get uncomfortable as citizens, obviously, because we're sophomoric about all this stuff. You know?
Sure,
We
I
don't know.
absolutely understand the question.
But you get nervous when you start getting different answers.
As we move forward and talk about cessation of potable water, and I don't know exactly what that looks like yet, but it could take several years for the groundwater system to rebound, if that's the proper word, and come to a new stable, so. Question for a while, I think.
Thank you.
Thank you.
Excellent presentation, Lowry, and I wanted to thank you for making quick adjustments based on the comments that I provided last night. It's much more focused on the audience, so it's excellent. And as far as the dilution issue, when chemists think about dilution, they're thinking about diluting the sample, and that's the difference. We're talking about a different macro process here. But the only other comment, and there was no confusion as far as I was concerned, but on slide 3, I just wanted you to emphasize, if you would, for the audience, that you're talking about 1,4-dioxane and dioxin, and they sound very similar, but they're different animals.
They're completely different, and that's why I put those up there, because people get them confused. So I wanted you to see this one, TCDD, super, super toxic. 1,4-dioxane, not in that category. Okay?
Less toxic.
Less toxic,
Yes.
well, not in the super, super toxic.
That's correct. Super is the technical term.
That's pretty good. See, we understand that technical term, though.
Super duper, that's a whole.
Oh, yeah, don't.
Are there other questions, comments?
Oh, that was great.
Go ahead.
I also thought it was wonderful, and thank you so much for the 3 bottles. That made things much
Did
clearer.
that help? Good.
Oh, yeah, thanks.
And clear in a murky.
Anybody thirsty?
Yeah. I just wanted to ask, in terms of your updating your technologies, how is it that
I mean, I out in your world, wherever that world is, you learn about new technologies and new techniques that come along, and is that automatically incorporated into your processes?
Usually it starts with the developer. I know at the state lab, we try to bring up methods. We try to bring up the 1,4-dioxane method. Unfortunately, we didn't have the staff or the money. And we did get a method, but it was not near the detection that private labs could put out there.
Okay.
Yeah, we try to, because we're at the state chemistry lab, we really try to gear ourselves to the public and helping the public. So we're always really big at trying to provide low-cost testing to the public. This was a method we tried to bring up, and it didn't work out for us.
Low cost isn't always helpful.
No, but because we're trying to get the purge and trap.
Yeah.
We're sharing that instrument with a lot of other analyses, so we weren't able to do it. But you are true. But as technology improves, cost goes down.
Okay.
Because there are things right now that you can get for $10 or $15 that back in my day were $1,500.
Yeah.
Like
So
an ICP-MS. I worked in a national laboratory and one of the first ones, and that's usually what it costs to run a sample.
So in my lifetime.
Well, thank you
Thank
very
you.
much.
Thank
I think
you.
we're gonna move on to
Okay,
the
yes,
next
yes. And
presentation.
anytime you guys want to buy me dinner, chemistry, give me a call.
You'll come back.
You guys are awesome.
Okay, yep, so hopefully.
Chemists have solutions.
Just come up with that right now. Okay, so, come on up.
Okay, is there a port that I can plug into
Janine,
or?
you sent your presentation to Janine, right? So she can, there you go.
I don't believe she has the animated presentation.
Is there cartoons?
Yes.
The Lowry Landfill info.com
Yeah,
page.
is that a PDF file that you opened up?
No, it's not.
Is
I
that,
backed out of the PDF so I could access the link.
maybe if we just go a couple slides into it, just to make sure. Yeah, it's not animated.
So somebody sent, it might have been Jennifer.
Well, could I just,
You said the PDF, see that?
yeah,
Can he plug in to that?
that would be the best thing to do.
Because it won't stream.
It won't stream. Not unless you want to give me the presentation, put on here the way you
Sure.
see it.
Sure.
You can do that.
So okay.
My son's studying to be a chemical engineer, so I decided that I could chemist solutions.
Hey, Ryan, if the lunch camera is off, does that mean it's not streaming?
Steve, are you talking about the shrinking plume?
No.
Because it was off for quite a while.
In July.
No.
So we're fairly.
No, it's not. I'll send you over the presentation.
19 years. Yeah.
Have you
sorry.
got that berm around your
Well,
property?
we did. It's kind of a long story, but this company dumped dirt and then they never would come back
Are you
and fix
emailing
it. So that's
No,
just
I will bring it over on
where
a
it's at.
thumb drive.
So, because it was supposed to actually be more in the front, they just kind of come out and move dirt.
Oh,
And it's like, well, we didn't want it there, we want it out here and stuff. So it's kind of been weird here, but we've got a friend who does excavation. And so he's gonna come out and actually, and we want to put most of the dirt in front of the property. Just noise and then safe. Yeah. No, when they originally contacted us 3 years ago, it was just supposed to be 2 small berms on the east, or the east and the west of our property. And more of just to dress it up, or just, yeah. But then they just dumped this massive amount of dirt, and we've never been able to fix that. So now that with all the traffic and it is pretty soon, then we just decided we want all that dirt moved.
Hello.
labs and a multiplier for the PQL10. This time we wanted to get more aggressive, so we knew what lab we were going to use, so we only sent it to one lab. The two labs is that we sent it to our backup lab too, but we only calculated the MDL from one lab's results, and after negotiation with EPA, we used a multiplier of 6 instead of 10. So we were trying to get it down as low as we could go and still be confident that the PQL would be accurate. We know the MDL, that's kind of a yes/no value, and it's not very accurate down that level. It gets more accurate as you go up to 0.9. And the last slide for me, this is how the performance standard has changed. Performance standards are in yellow. Originally, we were running a straight AB260 full scan. Thank you very much. And, 1,4-dioxane was just one of many compounds that they were analyzing. So the PQL was 200 micrograms per liter. So when the product came out in 2006 with their 6.1, we did our first PQL study. We used 3 labs and a multiplier of 10, and you can see that we got 5. The more labs you add, the more variation in the results, and the higher the MDL, and the higher the PQL. So over the years, Colorado got down to 0.35, so we needed to do a new PQL study, and that's when we got the 0.9. We have these, the PQL study report and a method comparison study. This is for non-isotope dilution methods, and we found that on average, they only achieved like a 66% recovery down at the 0.35 value. So we were not happy with that. Kind of confirmed our method was appropriate. And when you are biased low like that, you tend to get false negatives. So we didn't want to use them methods. So now it's time for Steve to tell you about the plume. So,
Hi, my name is Steve Funningsland. I'm a hydrogeologist with CDM Smith. I have about 30 years of experience doing hydrogeology. I'm excited to be here. I couldn't sleep last night and I had a dreaded dream, and everybody sees a blue shirt, right? I'm going to be talking about defining the north end and what we know about it. So just a quick site orientation, of course. We have the Lowry Landfill Superfund site here, Yale Avenue, Gun Club, East Mississippi, Gun Club Estates, and the Murphy Creek subdivision. I placed some flip charts over here just in case we get lost in the presentation. I can always bring you back to where I'm talking about. Next slide, please. Sorry. Okay, defining the north end study area. Where do we even start? We always start with topography, because topography controls both the surface water flow system and the groundwater flow system. The next slide is topography base of the site. So site orientation, Superfund site, Yale, Mississippi. Everybody okay on where we're at? Okay. Next slide, please. This is the groundwater plume that we're talking about. This is the north end plume. This is the north boundary barrier wall. This is the plume where it ends just south of Mississippi Avenue. It's based on the 0.9 micrograms per liter. So topography is controlling our study area. Let's go ahead and do the next slide. The red line here, the dashed red line, is the drainage basin. So on either side of that line is a topographic ridge, and then next slide is the topographic valley. So I think the easiest way, that's okay. I think the easiest way to describe topography is if you had a beach ball and you were to put that beach ball right here on that line, it would roll downhill all the way down here to 5 miles. That's what EPA wanted in this 2017 5-year review slide. So that's 5 miles down gradient from the site. On this side, on this topographic ridge, 5 miles, that beach ball would go along that line. If you were to put the beach ball on the outside of that drainage basin, it would go towards Coal Creek. On this side, it would go towards, Coal Creek, and this is Tollgate Creek. If you were to put the beach ball in between the basins, that beach ball would roll downhill and continue to roll down the topographic valley at the end of the 5-year study area. Okay, next slide. Surface water is controlled by topography. So once again, if we have a droplet of water, it acts very much like a beach ball. If it's outside the drainage basin, it's going to go into another creek. If it's inside this drainage basin, it's going to flow towards Murphy Creek and continue north. Next. And groundwater. Groundwater is controlled by both topography and surface water. So same thing. If groundwater is within the basin, it flows towards the topographic low and eventually follows the north course to the end of the study area. Just one quick thing to add to this is we have groundwater data across pretty much this whole area, and we know that it's convergent flow of the groundwater into this area here. So we are very comfortable and confident that this basin study area does capture all the concerns that would be a result of the Superfund site. Okay, what do we know about the plume? We know the width is approximately 1,000 feet wide. The length is 14,000 feet. We know that it's in the shallow groundwater, and that's confirmed by groundwater data collected from the site and from Section 31. And as Rebecca said, this is one of the topics that EPA and the state want confirmation to reduce the uncertainty of that. So we're in discussions with EPA on how that is going to be addressed. We also know from Landslide that it is within the EPA acceptable ranges. Next slide, please. We know that the plume concentrations are decreasing and the plume size is decreasing.
A quick question.
Yes, sir.
That's only talking about 1,4-dioxane, right? When you say its concentration is decreasing and the extent is decreasing.
Yeah.
You're not talking about all the chemicals, just 1,4-dioxane, which can be diluted and could result in that.
Yeah,
Okay.
if I could hold your question
Okay,
just for.
sure.
Okay, sure. And then the next thing is that there's no completed exposure pathway identified. Once again, Rebecca's brought that up earlier, that is something that is going to be further evaluated. Next slide, please. Okay, this is just a setup on the next slide. If you wanted to go to this the website, you would see the figure. Oops. Okay, so on the slide, we're presenting 2017 and 16 groundwater data. The surface water data is in there. It's to the 0.9 micrograms per liter. I think the most important thing here is addressing your question, is the 2017 EPA confirmation sampling documented that 1,4 is the only contaminant above the site-specific performance standard. So delineation of the plume, once again, this is Yale Avenue. This is Mississippi Avenue. This is, we're getting familiar with the shape of this plume. This is the 1,4-dioxane plume at 0.9. Next slide. This is the longitudinal extent. This is as far north as the plume extends above the 0.9. And it runs from the north boundary barrier wall through Murphy Creek drainage to just south of East Mississippi. And I have a slide that I'll come back to and show how we determine that. And then the next slide is where we determine the width. Once again at Yale Avenue. Okay. And then just one other thing that's of interest on this slide is all the green monitoring wells and extraction wells with the green halo. Those are all decreasing concentrations, significantly decreasing. So that's one of the points that we can point to, or the data that we can point to that shows that the plume is decreasing in concentration and is decreasing in size. Okay, so once again, this is Mississippi Avenue. This is the north end. This is the very north end of the plume. Okay. Okay, this is groundwater flow direction. Groundwater flow is perpendicular to groundwater contours, so we know that it's flowing in this direction. We have, this is the furthest north monitoring well that we have that's above 0.9. It's at 3.3. Slide. We have 10 monitoring wells or data sample collection points that are all below the 0.9.
So they're still detecting it, just it's below the 0.9.
It's below 0.9, right. And so any detections that are between the MDL and the PQL has a J value to it, which means that it's estimated.
And so then how come you wouldn't consider the plume further down?
If you're getting the readings where your little green arrows are.
Well, this is the site performance standard, and you know, as we feel confident with that number, and if we're trying to define the plume based on estimated numbers, it's basically a guessing game. Well, I mean, the numbers we know is between 0.9 and the MDL, and this is the site's performance standard. So this is what we're showing.
So if it's under 0.9, then you consider it not part of the plume?
I wouldn't delineate it, it's part of the plume, but this is the delineation that given based on the site performance.
So it looks like that
One of the
below-
items to be discussed between us and EPA and CDPHE is it necessary to define a plume between the PQL and the state standard if you can't get reliable chemical results back from the lab?
So what the J flag indicates, as Steve had said, is those are estimated values, meaning there isn't that same degree of, the necessary degree of certainty that number that's being reported is actually the number. Especially when you're getting down to 0.35, the number could actually be well below, maybe down to 0.15, below the state standard. So there's uncertainty in that. There isn't that.
Maybe Lori could talk to this. This is exactly what her slides were trying to describe.
Yes.
And Margie, did you have a question?
Well, yeah, I guess two questions. One was, in my mind, there's a concern that the site specification had to be, and I'm going to use air quotes, negotiated with the EPA because it's different from what the state standard is. So that's one concern. And the second concern would be if you're someone who might potentially be affected by the water, I don't feel comfortable with having something estimated.
So, and Steve, I want to let you continue your presentation, but it sounds like there may be there's some questions and also, Maggie, I see you have a question. So is it about this slide?
Yes, it is.
Okay.
That's because towards the end of the plume that's delineated, you've got an estimated value of 0.54.
Yes.
Okay, that's within your delineated plume. You go further north from that, there's a 0.53 estimation. Why wouldn't that be included if you're already including
I'm
this other
sorry,
number?
that right there.
Right.
I'm sorry, that's a surface water sample. This is the most northern well that's above the 0.9.
So if you're saying the plume goes 3 sections past that, what caused you to select 3 sections past that? Why aren't you saying it stopped at the one that you're saying it's above?
Well,
I want to understand
sure,
how you're
yeah,
delineating
no,
this
no,
plume.
it's a good question. Okay, so we have a monitoring well there that's below the 0.9 value, and we have.
And I
this
can't see what it is, because unfortunately, the green line's right over the top of it.
It's 0.75, I believe.
Do it back up.
Yeah, go ahead.
Okay.
It's 0.75
And isn't
J.
that, it's an
So it's
estimate.
below the PQL of 0.9, but above the MDL. So it's estimated, that's why it has the J. And then we have this whole line of transects, wells along this transect along Mississippi, and those are all below point.
I'm not arguing that. I'm just
Okay.
trying to figure out why you've included the 0.54 in your plume
Well,
as an estimate.
Yeah, so if you were, let's just take, for example, if this was 10 and this is 1, where would you put a line at 5?
Well,
So we use our-
if it were 1, it would be over the 0.9, so you would have to.
Okay, I'm sorry.
So
Understandable.
it sounds like that the required study by WSDs, by the EPA, is based upon 0.9 only. That's it. Because these are guesstimates up there.
That's what I'm showing here, I believe.
I mean, that's your study.
That's
Whether we like it or not, I mean, that's what you're studying, because you're told to.
And I believe Rebecca has stated that EPA and the state are working with WSDs.
Gotcha.
And we continue to look for lower detection limit methods or.
But you can't use them because you're only looking at above 0.9 on your study.
Oh, no.
Are you allowed to look To look?
That study, the PQL study,
Uh-huh.
tries to get the lowest number possible. And that's the best we can do. That's the best technology is allowing us to do that.
So Richard, when we submitted our 7 samples we submitted them at 0.35, we submitted them, I think, at like 6 and 1 at 9. We couldn't pass couldn't be measured for certainty, the required certainty of a 4 PQL study at that concentration. So we tested it at the standard, couldn't
do
the certainty standard.
Thank you. Got it.
Did that help? Did that answer that?
Yeah, you didn't just go 0.9, you went 3 or 4 different types lower. You couldn't
Yeah,
make
we had
certainty.
3 different concentrations. I think it was 2, 4, and 8 was what we used.
So that's why you use the J with it? The J, that's why you say it's an estimate?
Well,
J stands for.
after all the
J stands for.
calculations,
Right.
and you get the MDL at 0.15 and the PQL at 0.9. Anything between 0.9 and the 0.15 is estimated.
Okay.
That's why it's J. And the closer you get to 0.15, the more varied that value is, the less you can trust it. It's basically a yes/no. When you get down that low and in that area, you know it's there. You don't really have a good number for it, but you know it's there.
Okay.
So I have another question.
And before you ask your question, I want to let Steve keep going, but is it about this slide, or should we stay on the slide?
Yeah, it's about all this, okay? So my only question is, we know that there are drinking wells 45 to 50 feet that are very close to the
Projection of
the plume. People are drinking out of that. Okay, so you go there and you test it and you get a J factor that says it's 3.5. So we just get that off and let them drink it?
0.35.
0.35.
Yes.
Yeah.
Gotcha.
Do we just let the people drink it? Or do we test and see if it's there? That was my question for the whole thing. Because do not think that there's not 50-foot wells people drinking out of, because there are, we know them. So to say that people are not drinking this, that might have dioxin in it or not, we can't say that.
I
I'm done.
would suggest that's another line of inquiry. I think it's a good question.
Okay.
What Steve is presenting is how the WSDs have tried to define the extent of the plume. That's one piece of information. But the other piece of information is to be able to look at the risk. That's why I suggested earlier that I think it would benefit our group, and I mean me too, all of us, to talk about 1,4-dioxane and what are the risks posed by 1,4-dioxane. EPA has certain acceptable risks, if that's even a thing, but we have acceptable risks. The state has a number for 1,4-dioxane that's very conservative. So I think that's part of the conversation as well. We're not going to be able to answer those questions tonight, but I'm glad you raised it. And I think the risk piece is complementary to and as important as trying to define this plume.
Thank you.
Okay, Tom, and then Molly, and we're still on this slide.
Yes.
Yes, sir.
How are any of the numbers that you've given us affected by the fact that you put in for 20 years, all this, diluted it with basically drinking water?
Sure, I addressed that a little bit later in the presentation, so when that comes up, if I don't answer your questions, then that would be opportune time. Cool.
Okay, my question refers to your legend, where the dotted line is an inferred, right?
Yes.
So this is your best guess, so to speak?
Right, so this slide is defining the length, and so if you go ahead and, right there, that's perfect. Okay, so for the length, we're showing that this is 3.3, and this well is 0.75 J, and so we show the extent here at this location. As we get along the sides here, we don't have a transect at this location that would definitively define the width of the plume. The next slide, I'll show you where we have that definitive information. But once again, we can utilize the data that we get from the transect that's up north to help us understand that we didn't, the plume did not go like this.
Okay.
The plume did not go. Groundwater flow based on water levels, and we have good control of that, is showing that this groundwater is traveling towards that.
Okay, and another question then that comes to mind is, what is this red line that you have? You're actually the red line, not the inferred line. What is that in comparison to, say, 5 years ago, 10 years ago?
Well, that's a great question. As you can see on this well right here, it's a green haloed well. It's decreasing. All the wells along the north end boundary are decreasing.
Okay.
Steve, do you want to remind, there's that really cool graphic, I don't know that we're able to show it here, but it's on the homepage and it shows that decreasing
Yeah, we have an
trend.
animation.
So to answer your question,
Okay.
it shows the change.
Oh, it is under.
Okay, thank you.
So even though you really want to continue,
I
Maggie,
really do.
I know, she's still.
You answered my question when I said, how did you determine that from the 3.3 micrograms per liter, that's a nice hard point that we know is above the levels.
Right.
How do you come up and determine that is the end of the plume? Where it's not dotted red anymore?
Right. So, this is a professional, standard of care. That the end could be here as well as here or as well as here, but it's somewhere in between those 2 points.
If I may jump in, it's a very good question. The statisticians will call it linear interpolation.
Okay.
And it's a statistical means to determine, okay, if it's 3.3 there and it's 0.75 there, statistically, where is the most likely point to be 0.9?
So it's
And that's what-
calculated.
It's calculated,
Thank
that's
you.
exactly right.
That's what I wanted to know. I didn't know whether you were measuring it, how you got there. Thank you.
Sorry.
But it's being calculated with an estimated value. So what value does your calculation
3.3 is not
have?
They're doing it from the 3.3.
No, the 3.3 and the 0.75.
That one just happens to be included.
No, that's a statistical thing you're using to calculate it. And you're
That
using a
solid red
estimate.
line could move north or south a little bit.
Okay.
And in fact, it has, over time, it was up here. And it's been decreasing based on concentration here. And this well was above 0.9.
So is it okay if we let him continue? Or Lee, you're.
Well, I just want to say, I, with all due respect, Steve, if you had confidence in the shape of the potentiometric surface, those dashed blue lines, they wouldn't be dashed. And as far as the terminus of the plume being solid, I don't think we can do that given we're interpolating with estimated data of 0.75. And my ultimate question, which we can't get into tonight, is how do we know that any of these numbers that are estimated at Mississippi or south of Mississippi are really what they are? I've heard it stated by 3 different professionals here tonight. The real word is, we can't use the J data for quantitative purposes. Lynn just said it's a yes or no. It's there. We believe that 1,4-dioxane is there, but we don't know if it's 0.75. I would like to get at some point into the statistics of, can we say that's a 20% error bar on that 0.75, or is it a 50% error bar? I don't know if you have the data to do that kind of analysis. I think what Lynn says, it's a yes or no. It's there, but we don't know what the concentration is.
And it's counterintuitive, but we do use those values when we do the stats.
Yes,
We take the J's off and we just use them.
I understand
So-
that. It's important for people to understand that there is some uncertainty with those numbers between 0.15 and 0.9.
But the closer it gets to 0.9, the more certainty we have.
Right, and back to this potentiometric surface, if we did have transects of data, then we could make these blue lines solid, but we don't really have that. We don't have it anywhere. I mean, you'd have it down there, I see part of that line is solid. So.
Right, if we were to zoom back and look at the north end as a whole, we do have transect data along the north end, so we are pretty confident that we know where.
Yeah, you got it at Yale and Mississippi. So.
Sure, and along the golf course as well.
Tram sites.
We collect data.
Yeah, thank you.
Okay, so the next area that I would like to go to is define the width of the plumes. One more time. Okay, so once again, here's Yale Avenue. Okay, this is section 31. This is the dad's landfill. And next slide. Once again, this is groundwater contour, groundwater flow towards the north. Okay, next slide. So we're getting better at this. Okay, so there's 5 wells that are above 0.9. Okay. We have 6 wells that are below 0.9. So we draw the plume between above 0.9 and below 0.9. Above 0.9 and below 0.9. Once again, I just want to point out that again, the green halos means that the concentrations in those wells over time are decreasing. If I could go back just 1 second. All right. This well right here, the B201 is non-detect. That's a deeper groundwater monitoring well. And the next slide is our deep groundwater monitoring network. So once again, this is Yale Avenue. Yale, okay. And what I've done here is I've projected, the shallow groundwater plume outline onto the deep groundwater monitoring networks. So each one of these green wells is a deep groundwater monitoring point. And if you look at the next one, you can see that the 4 points, 4 monitoring wells along the plume and north of the north boundary barrier wall are all non-detect 0.9. We have good confidence that based on site data and section 31 data that contamination is not moving into the deeper groundwater. However, as Rebecca had mentioned, the state and EPA are asking for confirmation of that, and WSD is working on that. Okay, here comes the injection of potable water. Everybody wants to talk about that. And then after that, I'll talk about the plume concentrations and then the aerial extent. So let's talk about injection real quick. So, okay. So this is extraction. This is groundwater coming out of the shallow groundwater system through a series of pumping wells, and this is the injection. So just some general things about injection. So injection has always been part of the north boundary barrier wall component. It's part of the system. It provides hydraulic control and containment. It also provides flushing of water from the injection wells back towards the north boundary barrier wall and towards the extraction wells. And then it is also a requirement of the water port decree. There's basically 13 extraction wells within section 31. There's 3 injection wells. We use injection trench from 1984 until 2011 or thereabouts. Okay, let's look at the next slide. So,
excuse me, just point of
yes.
clarification.
Yes.
Are you saying that the injection is part of the ROD?
It's part of the
Remedy
boundary wall containment system.
Is it part of the ROD, the record of decision? Is that approved as part of the record of decision? Was it a component?
It wasn't specifically approved in the record of decision. However, the record of decision also did not rule it out.
I think, and I would argue it's not a part of the components that were approved or by the ROD or a part of the component.
If you were a plant that had toxic waste, the state of Colorado does not allow you to dilute the plant, the waste.
Right.
And then inject it into the ground. And what you're doing is essentially that.
I think for some capture zone analysis, which is coming out of the 5-year review that EPA and the state has requested, I think that will show information showing that it has a very small significance to downgrading pollution, that most of the water that's injected at the 3 wells flow towards the north boundary barrier wall or is captured by an extraction well very close to them.
And my suggestion would be that, because we want to let Steve get through, I mean, this is information from lots of different sources. You all can process and digest information, and I don't think we should put people too much on the spot to explain things that
I don't think we should put him on the spot either, but I think, and I'm not trying to do that, I apologize if it
appreciate
looks that way. But this has always been a point of contention.
Yeah.
This is not a part of the record of decision. It is not approved. It was just an arbitrary decision, and we're concerned about it because right now we're concerned that the potable water injection at maybe 5 gallons per minute is causing this plume to look like it's going away. And it's really concerning to us, and we want that on the record.
Right. Yeah,
And it's not you we're trying to attack at all.
concerns.
You're giving a good explanation. We thank you. It's not you.
And that's why the work plan that we're submitting for cessation, we can't just turn the spigot off.
Yeah, you could.
Well, listen to me. In order to answer the questions that you're asking,
Yeah,
one needs to have the appropriate monitoring in place to
absolutely.
do that. That's part of our work plan that we're submitting.
I really appreciate it, but we feel it should have been done a long time ago. So we weren't waiting now. How long are we gonna have to wait for this to show whether or not it's working or not and what the results are gonna be? Another 20 years?
And
That's
the
our
longer you
problem.
wait, the more you push the contaminants forward that you've already pushed all the way 3 miles now.
I understand that that's your hypothesis. At this
Right.
moment, it's an unproven hypothesis.
Well,
Right.
and
So-
so my suggestion is that it's duly noted. I mean, I think it is really duly noted. This is a major concern of the CAG.
Yes.
It's absolutely going to be a major topic of discussion with the CAG's concerns really strongly.
Can I just put one point on the record? One
Okay.
point on the record?
Yeah, go ahead, Jeff.
Based on the blue line and the extraction, it runs from 150% of the injection or the extraction to a low of 25.
Yeah, so this is
And
about
Sonia, I
20
see your hand up there too, so let's do this side and then we'll
That's-
come to you.
This is about 20 GPM and this is 5 GPM. So just give you a reference.
Well, I'm just talking about the ratio.
Yeah.
If you look at the injection versus the extraction.
Maybe if I could just show a couple more slides.
Sure.
Yeah.
Sonia, do you want to get in here before we move the slides?
Yeah, I just have a quick question. This seems like a really key slide, and the numbers aren't really visible from either axis back here,
Okay,
to me anyway.
sure.
So I was wondering if we could get a copy elsewhere, and if that same data is represented on a figure, for example, that shows those extractions and injections
Right.
and the decrease or,
Yeah, look.
yeah, okay, so that's coming up?
It's coming up.
And we will have this available, right, for the CAG, we'll post it on the website afterwards? Yep. Okay,
Great, that's good.
okay, awesome.
Okay, so, sure. Okay, so, as you pointed out, up here is about 20 GPM, down here is about 5. During this period of time, WSDs have been decreasing the injection rate, and they were doing it through observational engineering approaches. They were turning it down, making sure that we still have containment, turn it down a little bit more, containment, turn it down a little bit more. This is where we're at right now. This is where we feel like we definitely have containment and the water is being pushed back towards the north boundary barrier wall.
Hey, Steve, for Sonia and the people in the back, you might want to just point out the years at the bottom so that they know because we can't see it.
Sure. One more slide. How about if we do that? Okay, so at this point right here is where injection is equal to extraction, and that's basically 2008 time period. Does that help?
Yeah.
And then this is 2016. 17, sorry.
So actually in 2012, it looks like you guys had turned it down and then turned it back up a little bit the following year. And was that because?
Actually, I can't answer that. How about if I get back with you on that? I'm not sure exactly why we have that little dip, whether it was a operational thing. I'm not sure.
Okay.
Okay, and then this is just showing, for the past 8-10 years, whatever, we're basically taking out twice the amount of water that we're injecting. Okay, next slide. Okay, on the next chart, this is important to show. So north boundary barrier wall, next slide. Hill Avenue, this is section 31 here. Okay, these are the areas. So area 4 is located just north of the north boundary barrier wall here. Next one, area 3 is located here. Area 2 here, area 1 here. Okay, so what I want you to take away from that is that area 4 is closest to the site. Okay, next slide. Okay, so this is 1,4-dioxane concentrations by area over time. So first slide. Okay, so this is area 4. Like I said, this is closest to the north boundary barrier wall. And what we see is what we'd expect. It has the highest concentrations of the contaminant over pumping time. It has the biggest decrease. And then as we move out in time, it becomes much flatter. Okay, next slide. This is area 1, and this is the furthest away from the north boundary barrier wall. So it's just south of Yale. And once again, lower concentrations, lower steepness of that declining curve, and then once again, you have that real flat line. Okay?
A question.
Yes.
What's the blue line that comes out at 2008 and then looks like it goes into, it has 2 different paths?
They're 2 different colors. Oh.
Yeah,
They're really not.
Oh, I see.
Why is that?
I believe on the chart, we just added a 2B, and that's monitoring well 160, and that's always been a little bit of an outlier, if you will. It shows higher concentrations than most of the wells within section 31. It's an area that WSDs are looking at to determine if there's a better way to approach extraction from that area.
How high?
I believe it was 16 micrograms per liter. I would have to go back and check for sure, but it's in that area. Okay, this is that point in time that we were talking about where we went from 20 GPM down 5 with the injection. Okay, so next slide, please. So after the injection was significantly reduced, we would expect to see a little 1,4-dioxane rebound in especially area 4. And we do see an increase here at 2012, but we don't see a major spike in the system. And that leads us to believe that the potable water injection is being captured by the north boundary barrier wall or the extraction wells close by. I just want to explain something on this. You see a peak on all the areas in 2008, and you also see that peak right where I said we would expect to see a rebound at 2012. Those were dry years, and the system, when you have a dry year, you usually have an increase in 1,4-dioxane concentrations in those areas.
It's not diluted, isn't it?
This would be the animation, so I don't know if we can show that, but we could go to the website. That's based on data collected from 2006 to 2016. It shows that the plume is decreasing in concentration. There's, it's sometimes referred to as a heat map. Hotter colors, red colors mean higher concentrations, cooler colors, blue, mean lower. And as you'll observe, that the plume is turning blue. And that's what we all want to have. Okay? Okay, just a quick summary. We know the width and the length of the plume. We know the depth of the plume is limited to the shallow groundwater. We know the concentrations are within EPA's acceptable limit for Superfund sites. We know that the plume is decreasing in concentration and extent, and there's no identified exposures. And I want to caveat that with something. And WSDs are actively in technical discussions with the state and EPA on how to increase the certainty on almost every one of those things. So I hope that you invite me back and I can report on what we find.
Really?
You wanna come back,
Thank you very much, Steve. And I know that this raises more questions and it answers also some questions, but of course raises a lot of questions. We're almost at 8. So I guess what I would like to know if there are anything that came up today that people want to
Wake up.
on the agenda to visit at the June meeting because it was provocative. And also I want to just confirm one of our plans for the June meeting. So first of all, just regarding the presentations, is there any follow-up people want to see happen for the June meeting so that there can be discussion that needs to happen? Follow-up discussion.
Follow-up from what we heard today? Is that
Yeah, and follow-up questions that people may have, knowing that one of the things, Rebecca started this meeting by saying there's discussions happening exactly on these topics between Worcester Independence and EPA and the state starting next week, and there may be some things to report from that.
Well, she's gonna have meetings, and maybe we can find out what's up during the next meetings, what you come up with.
I think that's a good idea. We can provide an update in June.
Yeah.
And I haven't had a chance to look at the schedule in detail, but hoping that it lines out when we might expect to see work plans for various activities to answer the questions. And that might help us tee up what topics to consider as we get work done. We're going to try to prioritize those and level of importance.
So what is the CAG's role when the work plans come out? We used to be able to review the work plans and comment on the work plans. Is that a possibility now, or have things changed? For a long time now it's been, well, after EPA signs off on them, then we'll let you look at it, but then the decisions are already made and our concerns are not considered. So what is going to be the plan going forward with the work plans?
I think we could make that look like a lot of different things. Some work plans you may be more interested in than others. I'm not sure exactly what the status is of your TAG grant and hiring your own technical expert. And so the TAG advisor might play some role in reviewing work plans. So I think there's a lot of flexibility.
I'm moving along asking CISA where we're standing. We had to wait for our, I think it's 100-day for other people to join in. Is that right, Jennifer? We had to wait.
I can't remember how many days it was, but I know there was a waiting period.
Waiting period.
I think it's 30 days.
To see. Yeah, I thought I'd email him tomorrow. I'd try to get back on that, but we're going ahead with our plan to bring on technical advisor that would come to these meetings. And if there's a technical meeting, our technical advisors used to be included in the technical meetings so we could be brought along. So I think that what we're looking for is just an opportunity for us to review the work plans at least and give you our considered opinion as average people impacted by the site. That's basically what we're looking for. And then when we get our technical advisor on board, we'd like to have them more involved on our behalf.
I would agree. So let's kind of feel our way through that. Okay. Certainly what EPA would like to see is the meaningful engagement of members of the CAG and the TAG as soon as you get your advisor on board. It certainly wouldn't be our intent to do all the work planning behind the scenes and then issue a final document when it's too late.
That's really good news, Rebecca. I'm serious. That's
Thank you.
wonderful news.
Yeah.
Because since 2005, it hasn't been that way, and it's just been so frustrating because we've had so many comments that we thought were important and they weren't pertinent because it was already approved. And so you're making us feel more secure in our participation now, so we really appreciate it. Thank you.
Absolutely, and I think, like I said, we're happy to encourage that level of engagement. It doesn't mean we're going to agree with every comment that you guys have.
Absolutely, that's okay, as long as we get to say it.
Yeah.
You know, like tonight, we had some definite
You had
words we
some
wanted to
comments.
say, and we thought it was important we say it. But we do appreciate that it's moving forward, and believe it or not, we do appreciate the WSDs are actually
Absolutely.
moving forward, being honest and open, I think. I don't know. I think you are being honest and open with what work's going on and what you're planning on going forward with. And I'm especially pleased tonight personally to have BTW here because I have a lot of respect for their work, and knowing they're doing work for EPA, I really hope it goes forward. And so I think some good things are happening. I would only like to, I noticed some friction here among a lot of people when it was said, nobody's drinking our plume water. We know nobody's drinking your plume water.
Yeah.
So that's only going to raise the ire of the community because we know that plume could have been in that creek bed and in that waterway
Yep.
for more than 20 years. So you can't tell us that you know who's been drinking that plume water. But are they drinking your plume right now? No, we've never said that. So let's try and get rid of some of the friction by making that clear that that's not what we're saying. What we're saying, that stuff could be clear down into Coal Creek by now, or even on over into Sand Creek.
You know, and one of the things that we could do going forward also, especially because we've got all of us here, is to figure out things that just principles for discussion that would be helpful for you all CAG community members to hear or not hear that may raise your hackles. I don't know what is going on.
It was wrestling in the sound.
Oh, you're right. If there's things that raise your hackles that you hear from each other, I think it's useful to convey those to me, convey those to, and we'll just have agreements going forward about here are the things that we're going to try to refrain from saying that raises each other's hackles.
I don't want you telling on me.
And I'm not saying do it now because we're over time, but I just, in the future, let's figure out what those things are and try to refrain from them. And my guess is that it goes all, that this applies to everyone. Okay. So before we break, Sonia had something she has been wanting to ask. Another thing.
I'm still lost in the last presentation. I have another question. You said that there were no identified exposures. And so I was wanting to know, were there active epidemiological surveys or assessments that were used to determine that there are no identified exposures? Or am I misunderstanding the term identified exposures?
And I'm going to just say, if it's not a simple answer, that maybe this is something that could be addressed at the next meeting.
I just wanted to understand what your term was.
I think what it means is current human exposures.
We're not aware of any. So you're not aware of any, but
That doesn't mean that
done
there's been
active
slugs.
surveys or
Right.
assessments to determine whether there's happened?
What may have occurred in the past, it sounds like you're
Right.
concerned about.
Or to present?
Yeah.
I don't think there's been any epidemiological
Nothing
studies
popped out
done.
at you is what you're saying.
Yeah,
As opposed to
and-
we assessed it and found there definitely were no. That's a difference.
Yeah, and would you get that information? Would there be any epidemiological studies? Would that be information that would be sent to you?
No, I think that the statement that we have made is in relation to how would someone, a receptor, become a human receptor, become in contact with that material.
Yeah.
As EPA has stated, the primary the exposure pathway, the circuitous road that contamination would have to flow in order to come to a receptor is the drinking water pathway. EPA in the 2007 and 2012 5-year reviews looked at other types of exposure pathways and said that they either do not exist or they're irrelevant. That is dermal contact, incidental contact in the pond or in water, and inhalation. So vapors coming off the.
I really got a question about
Wait,
that.
but Tom.
This is really important.
No, I
because it's
know,
been
but
brought
I'm
up
just saying,
twice.
I might suggest that this is also a topic for the next meeting if we have.
Yeah, because EPA, she just said that.
Do you want to put the question on the record and we'll?
Okay, I'll put it on the record.
Put it on
It's
the
two parts.
Okay.
One is, according to the most recent technical fact sheet, inhalation is the most common route of human exposures. And exposures may occur through inhalation of vapors, ingestion of contaminated food, water, or dermal contact. Yet it was said, as I heard it, unless I misunderstand it, it can't be inhaled. The other question, and so just that needs to be taken into account when you're having your discussions as to whether or not people are exposed. And then the other question I have is I think I fully understand what you're talking about, the dilution, but I think it can be interpreted in different ways. So I hope that in your discussions with the CDPHE, EPA, and work study defendants, that you take into account all of those questions, because I don't think any of us have proof, definite proof, and say, okay, if we don't have definite proof, what are the things that we're really concerned about? And how can we figure out whether or not they're a danger to the community? Is it really gone all the way to Coal Creek, and should we test it out there? Or I think you understand what I'm trying to say.
Yeah.
It's a lot of nodding heads, and I'm just recording them, your questions for the record, because especially your first one, both are issues that we could take up. But not, Sonia, I'm feeling like we need to wrap up, but go ahead. Put it on the record at least.
I was just wondering, so it sounds like the answer to my question was identified exposures. No, there was no active process of, epidemiologically seeking out, door-to-door surveys or whatever. There wasn't, nothing like that. So really what you're saying is that it's your guess, your expert guess, that there probably wasn't an opportunity for exposure. Although Tom's point with the vapors is well taken in terms of wastewater and other routes for, contamination.
Well, and whose job is it? Is it your job to do the study, or is it the health department?
And that statement, categorically, no identified exposures, that you might want to rethink that.
Well, and Sonia, is it fair for me to just point out that there is a concern, at least from you, but from the CAG, about whether or not that's really, there's been a real assessment of epidemiological exposure and that can
Right.
be given.
Well, my
Can I
concern
just-
is that you make a statement, a categorical
Uh-huh.
statement that's not based on science.
And a request, okay.
Can I respond to that, or are you just really trying to be done?
I'm
No.
trying to be done, but can you?
I want to hear.
Go ahead, please.
I think one of the things that we want to do is confirm whether or not there are any exposures. And EPA doesn't do epidemiological studies, but we do prepare risk assessments. So we can look at where people might be exposed, most likely through drinking water, through whatever their water supply is, a private individual well. So we need to confirm whether or not anybody's using groundwater that might be contaminated. Sample those wells, find out what the contamination is, and then we have toxicologists who can prepare that risk assessment and identify what an unacceptable exposure limit might be. And that kind of circles around to one of my first comments this evening. I think it might be interesting to invite an EPA toxicologist here one evening, doesn't have to be in June, but just to talk about what is 1,4-dioxane and what do we have to be worried about.
Are we talking about that? Yeah. So we've talked about that before.
Yeah, we put it off because we wanted, well, we
Not
put
yet.
it off because we
Not
wanted
yet.
this information.
Let's see if they're drinking it.
Yeah, that's
So-
true.
So in wrapping up, can we identify the things that people really do? We started off the meeting with some suggestions from the CAG about what we could do in June. Then we've had this provocative discussion, knowing that a lot of these things are pertinent and are going to be being discussed soon among the agencies and WCs. What do people want to see on the June agenda based on that? Yes.
May I just say that from our last work study session, exactly what I said, opening up is what's important right now to us as CAG. We want to quit talking so much about a dioxin plume and focusing on the dioxin plume and start understanding the infrastructure, whether the leachate from the Superfund site is impacting that partial infrastructure that's in between Jewel and Yale. And we would like to focus more on leachate more than dioxin. We think tonight was excellent. Anyway, I do, and I saw everybody asking really good questions, and we really appreciated it. But we just feel there's so much focus on dioxin. We're not focusing on the fact there's other things coming from the landfill that we need to figure out if they're there too.
So for the June agenda, if you all talk with Sean and Karen from
Yes.
Aurora after this meeting,
Yes.
is it sufficient to have that, some sort of information discussion and plus an update
Yeah.
about what's happening with 5-year review?
Yep, that'll be quick. Yours will be
Does
quick.
that seem like?
Yes, very fast.
Does that work for June?
Yes.
See, nodding heads. Rebecca, I think the point about toxicology has been brought up and has been noted as a agenda item that people are interested, but for a little break. Okay.
So can I just have one closing thing, please?
You may, and before you say that, I just want to note that the third week in June is June 21st. That will be our next meeting. And we'll figure
Okay,
out.
and I do have to mention, because this group lives in the northeast area, transportation study area, and there is a public meeting for that transportation infrastructure on the night of June 21st. So I wanted to make sure that you just were aware of it, in case you wanted to make
I like to go to that.
because they're studying all the different transportation issues. I know there are some out there.
Is there
Can
a
you
conflict?
say-
between
Any
this
conflict
group?
on this? So does anyone have a major conflict with that date in light of what Karen just said?
If this is your priority, I just want to make sure.
I'd like to go to the June 21st meeting myself.
So if we don't do the 21st, we probably have to postpone it to.
Well, I'm only one person.
Well, why don't you go to the transportation meeting and report to
And
the rest of
report
us?
back. You're being hard.
That's cool.
All right,
I
for
can do
now,
that.
we're doing the
I
21st,
can do that.
and we'll
Somebody needs to
we'll
go.
negotiate with John after the
Okay.
meeting.
Karen,
Well,
I'm gonna go to the 21st meeting.
You're gonna have
Okay.
to tell me about it. So
Okay,
I'll
but
be here.
I think we're gonna break with many thank yous to the presenters, but first, Bonnie, you want to say one thing and then we'll clap and.
Yeah, right.
Go ahead.
Maybe.
I just want to thank Denver Waste Management for putting on the dinner tonight. Usually it's Tom and Emily, and they do such a good job, and tonight was good too, so
Yeah, I
thank you
heard
very
about
much.
Thank you.
legendary nuts last night.
Yeah. Did you get your menu? I mean, yeah.
We'll have a bigger room. Thanks to the city. All right, everybody, have a wonderful night. Thanks again for the tour and dinner.
Thank you.